Hi, I'm Marcel Beemster, I'm the CTO of SolidSense, and in this video I want to show you how SuperTest finds an error, what you see then, and then how you can analyze and understand what's going on and why SuperTest thinks there is an error in your compiler. I've got here a standard installation of the latest SuperTest, nothing special, so I'm going to start here and make the modifications that I need. I know this is a C99 program that I want to show, so I'm going to configure SuperTest to find that particular program. So here I'm telling SuperTest that it has to behave as if it's a, the compiler as if it's a C99 compiler, and I make it pedantic, so it makes it a bit more precise. I'm using the standard host compiler on the system, and let me show you what that is. That's cc-v here. That's a recent GCC version. That's the latest on this Ubuntu system that I'm creating the video on. I want to modify the test list. The test list defines which test we're going to run, and I don't want to run the tests from the core suite, well, just that part, just for demo purposes. Remove the other parts and include a section from the C99 suite. So this is a subset of the C99 suite, and that's where the error is. I'm ready to run SuperTest. Calling the test driver valid with the -b option for batch running, the -p for the progress bar, and the default configuration that I just modified, adapted for C99. Here we go, 129 tests. That doesn't take particularly long, so we're ready to view the results. For that we use the SuperTest report program, log report. The results are stored in the log directory, so I'm giving that to log, and here we see what's going on. Well, there are not many compile time errors, actually no failures in the compile time section, but there are some checks, which means that diagnostics have failed. Well, I'm not going to discuss that now. Now we're going to focus on a runtime error, because for functional safety purposes runtime errors are the critical errors. So here we got one failure in the C99 suite, and I want to zoom in on that feature, so I'm asking for a full report from the log directory. Now we get more detail, and indeed here at the end we get our problem. It's in this particular test. Let me copy this to the side so we can refer to that later. And well, now we can zoom into our program, because now we know which program has failed, and we can ask the SuperTest driver to compile just that one. Now we get the same results here. The compilation of the program is fine, there are no warnings, compilation succeeded, and then we have in testing, we have a failure. So we get the same failures here. We see that is reported also in our the log report that we saw earlier. Now, thanks to running it by itself, we can now go into the working directory of the driver. And here we find copies of everything we need to analyze the problem. So we know now which program it is, and we can compile and run it here. Now, first of all, let's take a look at the program. And here we see what's going on. Now this program is about a particular initialization syntax, which is added in C99 and which may not be familiar to you because it's a relatively obscure feature. But it allows you to initialize specific named fields in a structure. So here we have a structure of type T, so that's this type def over here, and here we see that it has a field K, and that field K is specifically initialized here. The field L is initialized here, the array subfields are initialized here. So that's the basic idea of the test. Now we also want to know, yeah, what does this mean? And I can explain it to you now, but the real reference is of course the language standard. So we have to go to the language standard, and for that we take a look at where this program, this test is located in the suite, and it's in section C99.678. And that means that we can go to the language standard, and we go to section 6.7.8, and indeed this deals with initializations. And here we see the initializer list syntax, and the initializer list syntax has elements here which optionally have this designator opt. That is designation. That is the thing that is added in C99. So you can write this designator list specification of what you want to initialize precisely in the structure. Now, the standard has some examples as well. The real semantics is defined in the intermediate part. This is rather a long section, so a lot of details here. But here, at the end of the section, we have a couple of examples. Now, this is a simple example, initializing a structure with two fields, .quad and .rem. Here, a more complicated example, because this is an array of structures. And then we see that the first element of the array, addressed by 0, and then the field A of that first element in the array, field A, which is itself an array, should be initialized with this initializer over here. And then the second element of the array of structures, and their field A sub 0 should be initialized with 2. So this is a way to initialize sparse structures, sparse initialization of structures. The exact semantics is defined above, and we'll go back to that later. So let's go back to our program, and we can take a look at what's going wrong here, because the test complains that the value here is wrong. This expression is wrong at line 42, and this expression here is wrong at line 44. So let's go take a look at those fields. Here we have the line that's failing, and we see that there's a value expected for y.t.k, and it's not right. It's not 42 as expected by the test. So let's print what this value is. And also this one, y.t.a0 is also incorrect, and in order to run this we have to include standard IO. So I've modified the program now. This is a copy, so the real SuperTest suite is not modified, obviously. And now I can compile the program with the comp script. It's using now exactly the same configuration that the test driver uses. There are no compile time problems, and I can run it with a run script T7. Here we go, and we get the same failure, so failures have not changed, and we see the value of field K here. It's 0 instead of 42, and the value A0 is also 0 and not 18 as it is expected here. So what's going on with this program? Let's see why the test expects these values 42 and 18. Now for that we have to show you how the value of y is actually initialized. So y is a structure here. It's a structure of type S, and structure of type S has itself a structure in its belly, that's T, and that's defined over here. So that's a nested structure inside S. So y is of this type S, and here is y is assigned a value from L, and L is initialized here. L is also an S, and here's the initialization. So there's something about this initialization. Let's just try to find out why the test wants this y.t.k to be 42. Now what happens in this initialization is that first the y field of the S struct here is initialized with 1, that's easy, and then the T field is initialized with X, and X is itself a complete structure, which is initialized over here. And here we see that in this structure, .k has the value 42. So this initialization here makes the .k field to be 42 and also the .a0 field to be 18. So those are set here in this nested structure initialization. Then the initialization continues because it sets t.l to 42. So t.l is a set in the same structure that's already initialized here. So it's overriding a field in this structure itself, with 41 in this case. And we can also see that this is one of the tests that has succeeded. So the 41 is executed, that's correct. And the same for this one, the final field is set to 17. And that's also correct because this cval verify also succeeded. Now let's do a bit of an experiment. Let's see what happens if we copy this line and comment it out and then remove those two additional field initialization, because it looks like this part, the .t equals x, has not executed at all, because the two fields that were not mentioned later on here, the two fields that are not mentioned, that is a0 and k, they're incorrectly initialized, they're 0. So let's see if this works. Maybe it's something with this complete structure initialization. Now let's see what happens now. We're running the comp script again. Program compiles fine, that's good. And we're going to run the run script again. And we see here now that we get still errors. But now we get different errors. Now the L field is incorrectly initialized. And that's correct because we commented that part out, or we took that part out. And the A1 field is incorrectly initialized. But the other two fields, the K and the A0 field, they are now correct because there are no failures here. So that is interesting. That means that the initialization of the substructure has worked if we write it in the second way. But if we write it in the first way, then something is fishy here. Now let's take a look at what the standard says. I'm going to restore the program in the original form. Let's take a look at what the standard says. And here we come to the art of interpreting the standard, because the standard has described this, but it is quite terse. It is in clause 19 over here. It says here, the initialization shall occur in initializer list order. So that means that the way it is written is also the way the initialization happens. That means that the complete structure initialization .t equals x is happening before the subfield settings. And then it says each initializer provided for a subobject that overrides a previously listed initializer for the same subobject, there's overriding there. So if there is a subobject mentioned again, that is overriding a previous subobject. And then, yeah, possibly there's an unclarity here about what subobject are we talking about. Because if we go back to the test, then here we are dealing with an overriding subobject setting. But what is the subject object? Is the subobject .t.l, which is the smallest possible subobject. That means that the other fields of .t are not touched. Or are we talking about the complete .t, which is reinitialized, and then there are no settings anymore for .t.k and .t.a0. Now it turns out that the GCC compiler interprets it in that second way. It interprets the subobject as to be .t here, and same here. The .t is overriding the complete initialization of t over here. So it takes the subobject to be .t. Now you can argue about whether that is a correct interpretation or not. The standard is quite terse, it's not very expansive about it, and there's also no example demonstrating this. So what we did when we wrote this test and found out that there was some disagreement here and there, we asked the standardization committee, the C standard committee, and they said it is the smallest object that we're talking about. So indeed the correct interpretation is that this initialization happens, the two fields .k and a0 are initialized, and then the .t.l is only setting those .t.l fields. Now we are not alone in this interpretation. I can show you that there are other compilers, and for that I'm going to modify the comp script. I'm going to go to the CC compiler and replace that by Clang in the comp script, like that. I can now compile the same program with Clang, like this, and we see here that we get some warnings from Clang. So Clang does compile correct, but it generates warnings. It says, okay, you're doing something with subobject initialization. Are you sure you do what you intend to do? Clang has created is a program, and when it runs, then it indeed passes the test. So Clang interprets the program as it is intended by the test suite, and it indeed takes the smallest subobject to initialize. So that completes my demonstration of how to find and analyze a problem. So first of all, we used SuperTest to identify what test is doing something wrong, and then we used SuperTest to zoom into that particular test. SuperTest gave us a complete environment to play around with the test, to modify it and to execute it in any way that we want. And furthermore, very important, the name of the test, the location of the test in the test suite gave us a precise location in the language standard where we can find about the semantics of this particular test. So thank you for your attention and listening to this video and watching the video. You can find us, of course, on our website, the contact page in Amsterdam. That's where we're located. You can fill in the web form or call us or send us an email, and we would like to hear from you. Thank you very much. Bye bye.